Hello friends, today's topic is hemostasis. So this is a process to prevent and to stop bleeding. Okay. It involves three major steps, that is vasoconstriction. Second one is temporary blockage of a hole in a damaged blood vessel by platelet plaque. Then third one is blood coagulation or formation of fibrin clot. So first one is vasoconstriction, produced by vascular smooth muscle cell and is the blood vessel's first response to injury. So smooth muscle cells controlled by vascular endothelium, which is releases intravascular signals to control the contracting properties. Then second one is platelets. So platelets basically adhere to damaged endothelium to form a platelet plaque, and then degranulation occurs. Degranulated, this process is activated by glycoprotein, which is found in plasma. So basically platelet play one of the major roles in the hemostasis process. When platelets come across the injury endothelium cell, they change the shape and ultimately become sticky platelets, express certain receptors, some of which are used for the adhesion. So adhesion of platelets to collagen. This is a process towards primary hemostasis. Third one is clot formation. Once the platelet plaque has been formed by the platelets, the clotting factor along the blood are activated in a sequence of events known as coagulation cascade, which leads to the formation of fibrin from inactive fibrinogen plasma protein. This step is called secondary hemostasis. Okay. Haemopoiesis. Introduction. Haemopoiesis is the production of all of the cellular components of blood and blood plasma. It occurs within the hematopoietic system, which includes organs and tissues such as bone marrow, liver and spleen. Simply, hematopoiesis is the process through which the body manufactures blood cells. It begins early in the development of an embryo, before birth, and continues of the life of an individual. Occurrence of the hematopoiesis. Hematopoiesis in the embryo, sometimes called primitive hematopoiesis. Hematopoiesis in the embryo produces only red blood cells that can provide developing organ with oxygen. So at this stage in development, the yolk sac, which nourishes the embryo until the placenta is fully developed, controls hematopoiesis. As the embryo continues to develop, the hematopoiesis process moves to the liver, the spleen and then the bone marrow, and begins producing other types of blood cells. In adult, hematopoiesis of RBC and platelet primarily in the bone marrow. In infants and children, it may also continue in the spleen and liver process. The rate of hematopoiesis depends on the body's need. The body continuously manufactures new blood cells to replace the old one. About one parent of the body's blood cell must be replaced every day. White blood cells have the shortest lifespan, sometimes surviving just a few hours to few days, while RBC can last up to 120 days. So, the process of hematopoiesis begins with an unspecialized stem cell. The stem cell multiplies and some of these new cells transform into precursor cells. The immature cells soon divide and mature into blood components such as red and white blood cells or platelets. Then types. Each type of blood cells follows a slightly different path of hematopoiesis. All begins as stem cells called multipotent hematopoietic stem cell. At each stage of a process, the precursor cells become more organized. First one is RBC and platelets. Common myeloid progenitor cells change 5 times before finally becomes RBC are known as erythrocytes. Platelets. CMP cells transform into 3 different cells. Platelets. CMP cells transform into 3 different cell types before becoming platelets. Then WBC. There are several types of white blood cells, each following an individual path during hematopoiesis. White blood cells initially transform from CMP cells into myoblast. Then the fourth one is T and B cells. To produce lymphocyte, MSC transform into cells called common lymphoid progenitors, which then become lymphoblast. So the lymphoblast differentiated into infection fighting T cells and B cells. Some B cells differentiated into plasma cells after exposure to infection. Impact on health. Some blood disorder can affect healthy blood cells in blood even when hematopoiesis occurs. For example, cancers of white blood cells such as leukemia and lymphoma can alter the number of WBC in bloodstream. Tumors in hematopoietic tissue that produces blood cells such as bone marrow can affect blood cells counts. So, hematopoiesis is a constant process that produces a massive number of cells. So, estimates vary and the precise number of cells depends on individual need. But in a typical day, they might produce 200 billion RBC, 10 million WBC and 400 billion platelets.